everyone, I'm Arya Gokhale and today we are going to look into another sorting technique. One of the main application of heap abstract data type is sorting. So heap sort is in-place comparison-based sorting technique, and it works by visualizing the elements of the array as a special kind of almost complete binary tree. The time complexity of heap sort is big O n log n. So the first step that is involved is to build a heap using the given array, and then we would then convert the heap into a maximum or minimum heap. For now, I'll go with max heap. And once the heap is converted to maximum heap, we would exchange the first element, that is the root or the maximum element, with the last element and then reduce the heap size. Then we would use the heapify function, that it is a method to basically rearrange the array into the maximum heap, and then we would continue this process until the number of remaining elements is 1. Let's start with first building the heap. So I'm going to pass the pointer to the array and the size of the array, and then this. So the structure max heap add two things. I'm pointed to the array, so I'm assigning the array that I've received, and it has size of the array. So now for is equal to max heap size. Keep this in a bracket. Needs to be divided by 2. Is greater than or equal to 0. Punishment I. Okay. And here I'll call the heapify function, which I would be defining. And I would have to pass max heap to it, and I, that is the index. Then you return max heap. So here we are doing max heap size minus 2 divided by 2. So what it does is it starts from a level above the leaf nodes, as there would be no need to compare the leaf nodes. So that is what we are doing. So now let's start with the heapify function. So what heapify does is it rearranges a heap to maintain the heap property. So the heap property in this case, as I am uh, doing this for a max heap, is that the root node or the parent node needs to have the key greater than the key of its children. So if I would go something like this, you are passing a heap, called it max heap, and you are passing the index. So the largest one is at index if passed, and the left child would be at 2 times of the index plus 1, and the right child would be at 2 times the index plus 2. Now we would check if the left child is less than the heap size, because we don't want to exceed that, of course, and maxi arrays left child is greater than maxi arrays largest. If that is the case, then largest is left and the same applies to the right child as well. So I'll just do this. And then we would check if we have the largest not equivalent to what it was before. Then what we need to do is we need to swap them. So we're going to swap this. So we're going to swap the largest one and the one at the index. And then what we would do is we would call heapify over here again. Because we are swapping, we need to check whether anything needs to be changed and whether swapping is creating any sort of change in the um, arrangement of max heap. So that is why we would call heapify over here again. So it is recursive. And then we would have to build our heap sort function. Okay, so sort, again passing the array pointer to the array and then the size. So max heap is equal to build heap, which we have done before. We would pass the array and the size in this case, and while max heap size is greater than 1, right, what we are doing is we're going to swap. This is the sorting one that we talked about. We're going to swap the first one, the root one, with the last array element. So at 0 would be swapped with this one. Okay, and then we would reduce the max heaps size and then heapify. So what we have done is we have reduced the max heap size and then we have called heapify and given the starting or the index as 0 in this case because we have swapped with the first element of the heap or the 0th position of the array. So this is where we need to check. Okay, so let's just check this once more. Let's test this for the array over here, see what we get. Right, 5, 6, 7, 11, 12, 13. So it's working. Let's test for another one. Okay, Control S. Minus 2099. So I tried with the negative number and also by giving it the same numbers, and it's still working. Good. So this is how you do the heap sort using the heapify method. There are other ways of doing it as well. I'll just give you the advantages of this algorithm. That is, it is highly consistent and it is using low memory usage because we are just iterating over the same array, using the same array to change things, swapping the elements of the array. So memory usage is also lower here, and it would not require extra memory space, unlike what we would need in merge sort or in quick sort. And the disadvantages would be it is unstable, it is a little expensive, and it is not very efficient when it comes to working with highly complex data. So that is it about heap sort. Thank you.